All right. So periodicity, or I like to just think of it as the periodic table. I think there's too fancy of a word. So you're probably wondering why we've just jumped around. 1.1 also talks about how the position of the periodic table can tell us about the chemical physical properties. So why have we jumped all the way to 1.3? Well, really important that 1.3 sort of talks about the periodic table, and I feel like when we were I was looking over these slides and I was discussing it, we kind of need to go through this first. So we kind of need to go through what is the periodic table and what is going on with the periodic table prior to sort of the mentioning of periodic table as part of our sort of unit of module 1.1. It's sort of badly planned out. So that's why we've sort of pulled this forward. So as you can see here, this is what a typical label in the periodic table is. So I'm hoping you've seen a periodic table before. I'll grab up. This is the VCE chemistry data booklet. So you get given this in exams. You get a similar thing in the HSC exams, but a little bit different. This is the periodic table they give you in that. So notice how these labels. So let me find carbon. Carbon's over here. This is the carbon label, very similar to this, although a little bit less in detail. Your one that you get will also be like the one that I have got up here. But as you can see here, it's carbon 12. It says 6 carbon, it says 6 and then C and then 12 and then carbon. So essentially the C refers to carbon. The 12 is the relative atomic mass, which we'll discuss, and the 6 is the atomic number. And there's some of the things that you're going to need to know when going through this. So this is a periodic table. This is a really big and massive periodic table. Now, Isabel went through and highlighted the molecules that you will need to know, or the atoms that you will need to know, the elements that you will need to know. These are the ones you need to know. You have hydrogen, lithium, beryllium, sodium, magnesium, potassium, calcium. You've got iron, you've got copper, silver, gold, zinc. You've got beryllium, carbon, nitrogen, oxygen, fluorine, neon, helium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon. So you will learn all that. And as you can see, sometimes it takes me a little bit more to process. It does happen. I've been going through chemistry since 2016 when I started doing Unit 1-2 chemistry, or Year 10 chemistry. And then 2017 I did Unit 1-2, which is preliminary chemistry. 2018 I did 3-4 chemistry. I've been doing chemistry since 2016. It's nearly a decade at this point, which is a very long time. It's still, at times, I have to sit back and go, all right, what is that? What is that again? What is that? It's that. And it does take time. It takes looking at this loads and loads to know what's going on. Now, I couldn't tell you the order of this now. It's something that I tutor yet. I couldn't tell you the order of this. I couldn't tell you the order up to 20. I had to learn that at year 11 level. I couldn't tell you that now. At your level, you should learn that. But if you don't, that's okay. You can get away with it. You get given the periodic table in all of your exams and all of your SACs, of your tests, etc. That's just what comes up. You get given this. So that's why, for me, I just think it's not as big a deal as what it's made out to be. And I think that's a really important thing. So as you can see here, these are the sort of molecules, atoms. I should say atoms. These are the atoms you need to know. Now, all these atoms fall into different sort of sections. And notice how this periodic table sort of has a sort of structure to it. It's a bit different, but it has a bit of a structure. As you can see here, you've got hydrogen and all of these sort of non-metals. You've got halogens, so halogens all fall in one group. You've got noble gases all fall in one group. And then you've got all your metals here. And these are also metals, but they're called transition metals. They're still metals, but they're called transition metals. So metals are usually here. You see this yellow line here. This yellow line indicates where metals stop. So everything on the left is metals except for hydrogen. And then all of these are non-metals plus hydrogen. Hydrogen is not a metal. It's its own thing. It's a little bit different. Notice how we call things groups and periods. So periods run across. So this is period 1 all the way to here. Period 2 runs here. Period 3 runs here. Now, periods refer to valence electron shells. That's going to sound like a very weird wording. We're going to learn about it soon, so do not worry. And then groups, these refer to sort of, they don't really refer to anything chemically, but they have points where they discuss what's going on. So your group sort of have similar properties chemically and physically at times, and that will sort of tell you what's going on. So really important, this sort of periodic table is like you're going to be looking at these a lot. You're not expected to know how to draw one out. You're not expected to memorize it. Please do not. It's a waste of time, but you will go through these. Now, as you can see here, groups are the vertical columns. 2 letters that reach downwards is a way of remembering it. You can just end up remembering it. I don't think you need some fancy way of remembering it. Periods are horizontal rows because they only have 1 letter that reaches downwards, so it's less. Look, if that helps you, go ahead and use it. If it doesn't, don't stress yourself with it. I don't think it's necessary for you to be utilizing little tools like that to remember it. I think you can remember it without it. Groups tend to share similar characteristics. So as you can see there, as I talked about, the groups, the vertical ones, they do sort of share similar characteristics. The periods, it's all about your sort of valence electrons. The groups we are concerned about are the alkyl earth metals, transition metals, halogens, noble gases. These last 2 are ones that you'll know really well. These first 2 you'll sort of know a little bit about, but it's not a really big deal. Halogens and noble gases, really cool. So, just a couple other things as well. There are other sort of things that are on the table that you'll learn as you go through that are different. So you have metals, metalloids, and gases. So metals are essentially just pure metals, such as aluminium, such as copper, such as steel, such as iron. These are pure, steel's technically not pure, so steel's not a bad example, don't listen to that one, but iron. These are pure metals. Pure metals that are shiny, they're malleable, so that means I can hit it really hard with a hammer and it'll just bend. So think about it if you've seen those, like, it's also a bad example because they're slightly different, but think of like, you've probably watched a movie or a TV show where they've used, they're like, the Camelot time, so like the knighthood times, and they're getting their swords and they're dipping it in the coal and they're hitting them with a hammer, they're pulling them out of the fire. Notice how they don't shatter. That's because they're malleable. They can bend, they can change. Think of it like that. Ductility refers to the ability to make a wire out of metal. So all of our wires in all of our machinery, it's metal, it's ductility. They're silvery. They have a high boiling point and melting point. They're really good electron conductors, which means, or electrical conductors, which means that they can conduct electricity, which is why we make them into wires in the first place, because they move our charge and therefore we have electricity movement. They're also really good heat conductors. What's a really good example of that? Pots and pans. Your pots and pans move electricity through, so that's also one thing that makes them really good. Metalloids, on the other hand, these have some metallic and some non-metallic properties. So some metalloids can be ductile, but also be colored, so they're not like silvery and shiny. Others are a little bit different. These are metalloids. You will learn which of these are metalloids in the periodic table, don't stress. Gases, these are essentially dull. They're not malleable, they're not ductile, they can be colorful. They usually have a really low boiling point and melting point, that's why they exist as gases. But if you did cool them down to a really, really cold temperature, far enough down that you ended up with, your sort of solid, you'd find that they're not good electrical conductors, they're bad heat conductors, they're not ductile. You'd find they don't have any of those properties. Now, the groups that we discussed before, your alkyl earth metals, these have a low melting point and boiling point. They're soft, they have a high density, and they're highly reactive. Now, we'll talk about our Gs in a bit, so don't worry about that. Transition metals, everything's different, so don't worry too much about it, but they have metallic properties, but it's really dependent on the element as to how strong those metallic properties are. Your halogens, these are gases at sort of STP, which is just room temperature, if you like to think of it like that. They exist in pairs of atoms, and they're reactive and they're colorful. So I want to talk about halogens very quickly. Halogens here are these molecules here. So halogens exist as pairs because they share their last electron. Now, we will discuss this in a little bit more detail, but essentially, elements want to have a full electron shell. They want to share. They want to share their last electron. They want to end up with a full electron shell. Now, a full electron shell for most of all of these will be 8. So especially these first two, they will be 8. And they've each got 7 because they're in the 17th group. This one will just have 2 shells. This one will have 3 shells because it's in the 3rd period. So being in the 3rd period and being in the 17th group, it has 7 in its outer shell. It's got 3 shells. Its outer shell has 7. It wants 8. So it will pair an electron with another chlorine. So essentially what it will do is it'll share one of its electrons, in a sense, to sort of share one back. So it gets sort of one back. Essentially what that means is you end up with this idea that with one of these electrons being shared, you sort of end up with 2. So you get one shared there, one shared there. So you end up with these shared sort of pairings, and you end up with this idea that you end up with an extra electron. So this is Cl2 in a sense. You get F2, etc., so forth like that. Now, apologies, we're still transitioning color. It's because I'm doing this at like 9 o'clock at night, and my computer goes into that blue light thing, the yellow light, non-blue light thing. So you probably just saw that there. I apologize for that. Nonetheless, going back, your noble gases exist as singular atoms. Now, this is really important. Now, I need to go back again. Now, these are because these already have a full outer shell. So why would I share anything? If I've got everything I want, why would I share? That is precisely what is happening here. So these don't share anything because they've already got a full outer shell. They don't want to do anything. They're pretty stable. They want to do what they want to do. So essentially, that's what goes on there. So that's what you need to know from each of those sort of groupings.